What did one snowman say to the other snowman? It smells like carrots out here. Anyway, this is the first course content video to be uploaded to the Geography at Penrice YouTube channel. It's a common sense, I should say, place to start. Section 3.1.1.1, which is a bit of a mouthful, but the focus is going to be on natural hazards. This would have been the first lesson you did all the way back in year 9, and the content we're going to try and cover in this video is over here in the content. In terms of these videos, obviously you all understand the concept, what a pause button is. If I'm going too quick, obviously jump it back, pause it. If you're looking at any of these notes that are going to appear on the YouTube channel video itself, then by all means add those to your own notes. They should be similar to what you did all the way back in year 9. Really important place to start here is simply the definition of a natural hazard. Could well be a 1 or potentially even 2 mark question in the exam. So we've got the definition there, just to really draw your attention to the underlying word natural. Human war or conflict does not count as a natural hazard because it's not natural, it's human controlled. So these are events that are outside of human control. Don't get me wrong, humans can manage these natural events, but they're not created by human beings. An earthquake is not created by human beings, so it counts as a natural hazard. It has the potential to endanger, so it means that it could cause damage or danger to human life, the economy and property. Don't get me wrong, you could also add there changing the environment, which would then endanger human life as well. We've seen some examples of that in Haiti regarding destruction of farmland as an example. In terms of possibly the new content underneath here is a risk index. In terms of natural hazards, there's such a huge range of natural hazards which affect such a huge range of places all across planet Earth that it's quite difficult to categorise natural hazard risk. This is probably the best way that I've seen of doing it. On your left hand side here we've got probability of the event, that's how likely an event is to happen, from 5 frequently happens down to 1 extremely improbable. Take the UK as an example here. Depressions are a frequent risk to the UK. River erosion is a frequent risk to anyone living in that area. However, it's not just the frequency of the event, it's also the potential damage it can cause, or what we call risk severity over here. For example, a large earthquake has the potential to be catastrophic, as we've seen in our Haiti example. However, a standard depression passing over the UK, as there is one outside that I can see now, I mean, the risks really are negligible to human life, the economy and property. So what we end up with is hazards fitting somewhere in this box. Okay, they can either be very frequent or very, very rare, and they have the ability to cause damage from catastrophic all the way down to negligible. So a real range of natural hazards that we need to be aware of in this course. In terms of the previous slide, I did just mention that there are a whole range of hazards. The fact that they are so large means that geographers try to categorise them into different events. The reason for this is to try and understand what sort of damage they generally do, and then to try and action any defences that we can if an area is constantly facing one of these hazards. So starting from the left-hand side, atmospheric hazards, created in the atmosphere, relatively straightforward. You should have studied hurricanes, convergences for Boscastle. Hurricanes, you might have done Hurricane Irma or Typhoon Haiyan. Convergence would be Boscastle. Depressions you will have studied previously. Heat waves, you might well have done the 2003 UK heat wave, a high pressure heat wave, or potentially even floods as well. Now floods is a bit more tricky because actually the event in the atmosphere, if you will, is heavy precipitation caused by rapid cooling, condensing of water vapour. However, floods would also fit into this category over here, which I'll come to in a minute, which makes it a little bit more complicated. Terrestrial, meaning on the ground essentially, or on planet Earth, or geological hazards are largely tectonic hazards, or hazards that are created on the surface, e.g. Landslides is your example there. Earthquakes and volcanoes you have case studies for throughout year 9 or potentially 10. Tsunamis you don't have, but at this point I just need to really identify that some of these hazards on this board are what we call primary hazards, some of them are secondary hazards. So actually your primary hazards are earthquakes, volcanoes and potentially landslides that actually lead to the secondary hazard of tsunamis. Any question on why might some earthquakes kill more people or damage more property? We can always throw in this idea of, well, if there was a tsunami, the likelihood is the damage would be higher. Although we don't study this at GCSE, we've chosen earthquakes and volcanoes as they're a little bit more common sense. Tsunami, Japanese for a harbour wave, is always an interesting one to look at for earthquakes. Lots of Boxing Day tsunami YouTube videos out there, which I would certainly advise you looking at just to see what the secondary damage of earthquakes can be. Water-based hazards, say floods, river erosion, coastal erosion. You've studied all of these in detail at year 10. Just to repeat here that you can consider floods to be both cause an atmospheric hazard, but also a water-based hazard on the fact that the river cannot hold the water, therefore it exceeds carrying capacity, therefore it's also a water-based hazard as well. Right, biological hazards is probably the most tricky of them. I've just put the word diseases up there for the time being, which hopefully the alarm bells are going off when you look at that. With diseases, we have got to categorise, clarify exactly what disease we mean. So some of the examples we can use here would be malaria or cholera, which cholera as an example is caused by a bacteria within dirty water or even potentially contaminated food. So you need to make sure we've got examples for each of the different types of disease. So a water-based disease or waterborne disease, I'd want you to go for either cholera or typhoid, or both really. Malaria, obviously, insect carried disease. Hepatitis, a bloodborne disease. You can also throw in rat bite fever here for one that is carried by a rodent. And airborne disease, if you need one, could simply be the common cold. So those are diseases caused by different factors. Those are the ones just to be aware of, that you can always categorise a biological substance that's causing those. In most of those instances that I've just said there, it's a bacteria or bacterium that is causing that spread. You guys, for your exam, are going to have to be aware of these 4 categories. You're going to have to be aware of these 4 categories, and you could get a question specific to atmospheric hazards or tectonic or terrestrial hazards, water-based hazards or biological hazards within paper 1. Okay, as was on one of the previous slides, it's really important for you guys to identify that natural hazards don't always cause the same amount of damage. They don't always cause the same amount of death. The reason for that is there are factors that affect the level of risk. As you can see there up on the screen at the moment, I've put 6 of them up on the screen there, and hopefully you can identify that some of these are completely outside of human control, and some of these are actually man-made, if you will. Looking there, population density, economic development as an example, are within human control, whereas size of the event and frequency is completely outside of human control. So you have both physical and human factors to be aware of here. Some factors are going to increase the vulnerability / increase the level of damage, and other factors will actually reduce the potential damage or actually the vulnerability itself. So starting with location, we'll take an earthquake as an example here. If an earthquake directly hits a populated area, we can probably all do the so what's quite quickly here. So there are going to be potentially more casualties on the basis that more people there are going to be affected. However, other large earthquakes that affect an area of a very sparse population, obviously this links directly to population density as well, obviously fewer people are going to die. Another point about location there for earthquakes is the depth of the focus. A deeper focus will generally mean that the seismic waves, when they reach the surface, will be limited in their power, as they'll be further away from the actual point of movement of the tectonic plates. Whereas a very shallow focus can potentially cause a lot more damage, as the seismic waves will not have dissipated so much of their energy prior to actually reaching the surface. So hopefully the location should be relatively straightforward. Do the size of the event next, right at the bottom there. Take a hurricane for this example if you want. How strong the winds are on a particular storm or hurricane. You know, the stronger the winds are, the more likely there is going to be to have flying debris, as an example. The more the lower the pressure of a hurricane, the larger or steep. Oh no, sorry, not steeper. Yeah, the larger the storm surge is likely to be. Therefore, more people are likely to be engulfed, or more properties are likely to be engulfed by water. Therefore, damaged. More people are likely to drown as a result of that. Size of the event you could also do for earthquakes. Again, obviously, the magnitude of the earthquake. The stronger the earthquake, the more likely it is that the ground will be shaking. The more likely it is that buildings will fall down. The more likely it is that people will be crushed by that falling debris. So really simple, straightforward so what's on this section. Hopefully you can see that as we're talking it through. Just don't overcomplicate this. It is really, really, really straightforward. We go to frequency. Take Haiti as our example. Haiti has been hit with numerous natural hazards, actually turning into natural disasters after the events. We have obviously got the Haiti earthquake that we've studied in 2010. Hurricane Gustav, which off the top of my head is 2008. Hurricane Thomas, which is 2010. Hurricane Matthew in 2016, I believe. All of these events are essentially complicating the initial event of Gustav, or the very large earthquake, where the country is struggling to recover from that and then gets hit by another natural hazard and struggle to recover from that. The infrastructure has not been recovered, obviously an LIC as we're aware of, and as a result more and more people are at risk of these constantly repeating natural hazards. So something to be really, really aware of there is the frequency of it. Alternatively, you can argue that the more frequent an event is, actually will cause less damage. More frequency equals the ability to prepare better for the events, and as a result of that, actually there'll be less damage and less deaths as a government can put in steps knowing that these risks are coming. In the same concept, if you will, a one-off freak earthquake could cause more damage on the basis that the area isn't prepared for it. If it's never had an earthquake before, there's less likely to be a plan in place. You saw that particularly with Superstorm Sandy, when it actually tracked so far north that it was affecting your capital city, Washington DC, which essentially had no preparation, no prior example of a hurricane or a large storm striking that area, and as a result more damage was caused. Go on to the final two that we're going to do. Economic development up there. Should be relatively straightforward. I mean, can the government of an affected country invest in technology to reduce the effects? If they can, you'd expect less people to die and there to be less damage. An example there would be earthquake-proof buildings, or potentially, in terms of hurricanes, can the country predict where hurricanes go? Can they use satellites to enable an evacuation plan to be put in place? Can they actually organise an evacuation plan? Are the roads or the infrastructure at a decent standard so people can get out? After the event, can search and rescue find people after the event? Can we invest in sniffer dogs? Can we invest in CO2 probes? Do we have a dedicated emergency response team? If so, actually, you've got less likely to have as many deaths on the basis that people will be brought out of the rubble. This is talking about an earthquake, obviously. Before starvation or dehydration. Take Haiti as an example, as an LIC. The economic development simply wasn't there. They had nothing of the sort to try to find people on the rubble, and as a result of that, more people died of dehydration and starvation. The final one, in comparison to New Zealand, which actually had all those things I previously mentioned. In terms of just geography, these are kind of like the specifics, really. What season does the event happen in? If it happens in winter in a country where temperatures fall below zero, for example, I know an earthquake, people trapped underneath the rubble are more likely to die of hypothermia or pneumonia after the event. The relief of the area, the geology of the area, can it cause landslides after an earthquake? Can you have lahars after a volcanic event? It's the thing. It's the almost like the get out of jail free cards, really, where you can pretty much name any factor which would naturally affect a number of deaths or injuries, and simply, as long as you can explain the reason why, like I just did with the seasons previously, you'd be fine. I mean, flip that. I mean, if the season's summer in a country where temperatures reach over 30 degrees frequently, actually more people, you could argue, would die because they would die of dehydration under the rubble. So all of these factors up on the board here can be explained in a fashion to make sure you can identify either more or less people dying. Just going to do a really quick exam question up on the board, just to go through the good exam techniques first. Outline, that means give a brief explanation. One, crucial, reason why the largest earthquakes do not, very important, underline that, always cause the most deaths. So essentially what we're being asked here is, sometimes the large earthquakes don't kill the most people. Why is that? Think back to your previous slide there. If I was answering this question, I would say economic development might be the easiest to explain. So I'd identify the economic development of countries like New Zealand, as your example there, could mean that less people will die in very large earthquake events, e.g. your Christchurch earthquake that we've studied previously. The reason for this is the ability of the country to invest in infrastructure, including emergency response teams, to therefore find people trapped under rubble faster, so there is less deaths. So we've now answered the question, so there is less deaths due to starvation or hypothermia. Anything you're not sure of in this video, please come and see me down in H7. More than happy to talk anything through with you.